Okay. Okay, last time we have learned a little about derivative, right? We have learned the tangent line and the instantaneous speed. Here. Okay, I hope you remember how to calculate the slope of a curve, the curve like this. I hope you remember the definition of the tangent line. This means the tangent line at P. The tangent line at P is the limiting position of the second line. This means as when Q approaches C and Q along this curve, we have this. Maybe I have this like this one here, like this. This line is called a tangent line. And if we want to find the equation of the tangent line, we must calculate the slope, right? The slope. And so we first calculate the slope of second line. We have known 2 points. We have known the coordinates. One is C of C, the other is C plus H of C plus H. So we calculate the slope of the second line. And by the definition, we have the tangent line is the limiting position. So we give the slope of the tangent line is the limit. This is H approaches 0 and second line. This means the slope of a second line. And in from this, we give this definition of the tangent line. This means we should know how to calculate this limit. Okay, or provide this limit exists. This means not infinity or negative infinity. Then we have tangent. Okay, and last time we have already calculate example 1. This is y is of sphere at 2, 4. We calculate the slope, right? Slope, this is 4. Do you remember? Right? Slope is 4. And then we have this is another thing, another questions or another problems. This is the average velocity and instantaneous velocity. Okay, and we give, for example, you drive an automobile from your dormitory to our classroom, and you take 2 hours, and you have take this is 80 miles. So we can calculate the average velocity. So this is 80 miles over the hour is 2, so it's 40, right? This is the length or the distance, and here this is the time you have spent is 2 hours. So the velocity, the average velocity is 40. And so this means average velocity is the distance from the first operation to the second operation divided by the elapsed time. But during our trip, we know during our trip, our speed is not average velocity, right? Now, for example, the speedometer reading was often different from 40. Maybe you drive a car, you can see the speed is not 40. So we want to calculate the speed. This is not average speed. And at the start, this means it registered 0 because you have to move. So the distance is 0, so the speed is 0. And it shows as 57. And then at the end, you also stop. You have go to the second position. So it fell back to 0 again. It's the speed from at the beginning is 0 and at the end is also 0. And just does the speedometer measure. Okay, certainly we know it's not average velocity. Okay. So, for example, we'll give a more precise example of an object P. This is the P. This is another. For example, P here. This is P for 16 t square feet in t seconds. That's in the first 16 feet in the first second, and 64 feet during the first 2 seconds, because we know this is 16 to square. During the first 2 seconds, this means when t is 2, we have this 16 times 2 square. So how is this is 64 feet. So it's far faster and faster as time goes on. Here, figure 9, they give the curve of the distance traveled as a function of time. This means if we like s is equal to 16 t square, this is a curve of this equation, 16 t square. And then during the second, this is when time. The time is from 1 to 2. Now t fell when s, the distance s is 16 t square. So when we consider an interval, it's from t1 and to t2. So we can calculate it fell is 16 times when t is 2, the 2 square minus 16 times 1 square. We calculate is 48 feet. And the takes from time from 1 to 2. So we have spent 1 second, right? 1 second. So the average velocity, we write is VAVG, is the this is the time we have spent. So the distance is 48 over 1, so it's 48 feet per second. But during the time interval from t is 1 to t is 1.5, and we also want to calculate the average velocity, right? The average velocity is the distance between this is 16 times 20 is 1.5 minus 16 times 1 square over we have spent 0.5 seconds, right? So we calculate the average speed is 40, and the first one is 48. And this is another situation when t, we calculate the time intervals from 1 to 1.1, or we calculate from 1 to 1.01. And we calculate the respective average velocities to be, the first is 66.6. This is 62.16. So we can say only during this time, the average velocity is 40, right? Velocity is 40. And so, but we want to calculate here. We want to calculate for example, the average, the velocity at t is 1, or we want to find the velocity at the point t is 2, or t is 3, or t is 3. we only have the result here. This one we only have during the second. This means the time interval from 1 to 2 have the velocity is 48. The time from 1 to 1.5, the average velocity is 40. And the next is 66.6, 62.16. But if we want to find here, it's not during this time, it's not during, this is during 1 to 1.5. But if we want to find when t is 1.5, so how to calculate this velocity? Okay, this is unknown. We don't know how to calculate a. Okay, and then how to solve it? We know the shorter the time interval is, the better we can approximate the instantaneous velocity. Okay, this means the time interval is 1.5. If we want to calculate when t is 1, this one, so we know we can approximate. This means this not equal. Approximate it by average velocity. Okay, it's not the same. But if we choose the interval like this, it's 1. It's 1.4. Okay, we can also calculate V1 by approximating it, right, in the time interval. So we can see when the time interval is shorter, here, for example, this 1.4, this 1.3, or from 1 to 1.01. 0.1, for example, consider this interval. From 1, I just say 1 point, like this one. I take this one here. From 1 to 1.01, we know the interval, this interval, time interval is shorter and shorter, right? So then we have the shorter the time interval is, the better with the approximate the instantaneous velocity at the instant t is 1. So we are looking at numbers 48, 40, 33.6, and we might guess 32 feet per second to be the instantaneous velocity. That's 48 in the interval. 48 in the interval 1 to 2. Okay, this one we consider is from interval is 1 to 2. Okay, and 40 we consider it here. And this 40 is 1 to 1.5. This interval 1 to 1.5. And this one we consider in interval here. In interval 1 to 1.1. 1.1. And this one is we consider. This is 1.01. Of course, if you guess the speed at the point 1, at this, at 1, maybe we can find this. We can guess 32 feet per second to be instantaneous velocity, right? Is this number is approximate the instantaneous velocity at time t. So this give us an idea how to calculate the instantaneous velocity. First, we should calculate the average velocity, right? And then we write p moves along a coordinate line so that its position and time t is given by. So if we write this is a position at time t, give ft. And at time c, here 1 is special. So we find a general number c at time c. And the object is fc. So this is distance is c, fc. And at the nearby time, like this, at time 1.01. So we can find another point is nearby time. We write is nearby time, we write is c plus h. Okay, c plus h. So we have the distance is fc plus h, right? And the time interval, this is c plus h, right? C plus h. And at c, you can find the distance is fc. At c plus h, you can find the c fc plus h. So we can calculate the average velocity on this interval, right? The average velocity we write is VA average. VAVG is equal to FC plus H minus FC over with time. We spend H. This is the time, right? This is average velocity. We know it's not equal to the velocity at point C. We can write it's about, right? It's about, we write the time at C is VC, okay? But how to find the accurate number of VC? How to find this one? How to find this one? You can guess how to find this one. This is just approximate VC. We can guess? Guess is not the accurate number, but I want to find this one is equal VC. This means VC is equal to which one? It's not. This just approximate. How to? You can see. This means the shorter the time intervals, the better we should approximate the instantaneous velocity. The shorter the time. This means the shorter the time interval. This time interval is shorter. This means how can we let this interval shorter and shorter? This interval is C. Here is C plus H. How to get it shorter and shorter? Yeah. How to get this interval shorter and shorter? Hello, students online. Please think about it, how to get this interval shorter and shorter. This time interval. Time interval is C plus H. How to make it shorter and shorter? See. Hello, students online. Are you listening to me? How to? It's just approximate the velocity at C, but it's not equal. How to get this is equal? The interval, the time interval, the shorter the time interval is, the better we should approximate the instantaneous velocity. Just get this interval, this C plus H. Maybe this means if we choose another point like this, right? So the interval is shorter, right? And we choose second point, interval is shorter, get shorter and shorter, right? This means the distance, this distance is approaching zero, right? So the distance is equal, this means we let h approaches zero, right? When we let h approaches zero, the time interval gets shorter and shorter, right? So if we want to find this instantaneous velocity, we have here this is average velocity. We take limit, let h approaches zero. Okay. Here, this is h approaches zero. This h approaches zero. Here, this is average velocity, right? Average velocity. Okay, so we have this definition of instantaneous velocity. Okay, do you understand it? Okay, and then in the case, we can calculate. In the case V, this means when F is 16 t square, and the instantaneous velocity at t is 1. Now, the case. Let me see. What's it work? 到4000了。你看。生气。 Okay. Let me see. And then we continue. We get this is here. Example 1. Here is the definition of instantaneous velocity. Now I just want you to okay, here. Okay. Now I delete the answer. And now by this definition, if ft is 16 square, we want to find the instantaneous velocity at t is 1. Do you know how to calculate it?
We can't see your
T
screen.
is 1. You can't see?
No,
You
I
can't
can't.
see.
Okay, wait for I want to see. Here. Can you? I think it's okay.
Yes, Lashi.
Yes.
Okay. Now here ft is 16t square. Now we want to find the instantaneous velocity at t is 1 by this definition. Do you know how to calculate it? Here we know this is at time t. At time t. This is at time t is this is time c. This is t is 1. So this means we should replace c by 1, right? So we calculate at the time t. We write this is v is limit h approaches 0. This is average velocity. Is equal to limit here ft is 16 square t square. This h approaches 0, and the numerator is equal to this is f c is 1, so it's c plus h. Oh, c is 1. This is 1 plus h. C replaced by 1. 1 plus h minus fc is f1 over h, right? Over h. And then continue to calculate this limit. H approaches 0. Here, f1 plus h. This means t square replaced by 1 plus h square minus f1. The t is 1, f1 is 16, right? Minus 16 over h. And then we simplified it is limit h approaches 0. Yeah, 16, we know this is a constant. So maybe we write here in front 16. So it's limit 1 plus h square minus 1 over h. And now how to calculate this limit? How to calculate this limit? We can find when h approaches 0, here the denominator approaches 0, right? So this 0, the numerator when h approaches 0, this 1 minus 1, this is over 0. So it's 0 over 0 form, right? But this is not the answer, right? And now how to calculate it? Do you know this equality? A square minus b square is equal to, you know this? Is equal to a plus b, a minus b. Okay, so here this is 1 plus h square minus 1. 1 we can write is 1 square, right? So it's equal to a plus b is equal to 1 plus h plus 1, right? Times a minus b is 1 plus h minus 1, right? So we write is limit h approaches 0 is h plus 2 times this is h over h, right? You know, h approaches, this means h is near 0. but it's not 0. So h over h is 1, right? It's 1. So we can find this is equal to 16 times 0 plus 2, right? And it's equal to 32. Right? So by this definition, we can calculate the instantaneous at C is anytime C. Okay. Hello. Any questions for this one? Hello, students online. Any questions? No. Okay. How about the other students? Any questions? Okay. If no, we continue. Okay. Here is one. Maybe 又卡了。You can exam 4. You can try to finish exam 4. This is an object. This is in Chinese is 初始的. Intently at rest first due to gravity. Find its instantaneous velocity at t is 3.8 seconds. And at t is 5.4 seconds. Here we give the function, the gravity, the function ft is 16 t squared. So you should calculate this one just at 3.8. Try to finish this. Instantaneous. Yourself. You. Yeah. Only you because. 于连去哪里了？睡过了哟。就 he's sleeping because Thursday I think he's always sleeping. Hello students online, try to finish example 4 only at 3.8. Okay, try to write the definition of the instantaneous velocity. Wow. Let me see. Oh. Okay. Or maybe you do it by yourself and just for me, I read it. Okay. Here, this example. You write ft is 16 t squared. Just calculate t is 3.8. Okay. What is? Okay. This is H is your procedure. Ft is 16 square t square. Ft is 16 t square. It's Ft t square. That's at this point only as 0.8. T is 3.8. No. See this 16t square. You got this square. No. Square here. Yeah. Minus. No. Why is just 16? You got C is equal to what? Yeah, right. 3.8. So it's 16 times 3.8 square. Right? This is 16 times 3.8 square. This T is we review the answer, okay? Here. This is we can first calculate the at time C. At time C, we find V is equal to this is FC plus H minus FC over H. Yeah, this means here FT is here. This means FT is 16t squared. So FC plus H is equal to 16 C plus H squared, right? FC, here FC is 16, C squared is not 16, okay? So minus, okay, we simplified 8 is equal to 32C. This is 8 times C, this is C seconds. If we want to find the instantaneous velocity at C, this means C is plus minus C is 3.8. So we can find the V is equal to, this means C is 3.8 is 32 times 3.8. And we can also find V here. T is 5.4. So we can find it is 32 times 5.4. This means we can find any time. We can find the velocity at any time. Understand? Hello? I think Lily. Okay. Okay, we continue. Then from these two problems, we have the definition of the derivative, right? We have seen the slope. We have calculated the slope of the tangent line and the instantaneous velocity. So maybe they have the same basic idea. So we can we choose the neutral name derivative and iterate two function and limit as one of the key words in calculus. So get the definition of derivative. We have derivative of function f. This is another function. We have another function. We write like this. This is f. And here we add this prime. This means prime. F prime. Read F prime. Whose value at any number here, at any number x is equal to F prime x. We write is equal to here, just like F x plus h minus fx over h. The limit h approaches 0. Okay, so we can compare the definition of the instantaneous velocity. We write instantaneous velocity is equal to limit h approaches 0 is equal to limit h approaches 0. This is f, right? This is t. at time t. So t plus h minus ft. This is over h. So you can see we choose a neutral name is derivative. The ft here, ft is not only the distance, okay? It's just a general function. It's just a function, right? It's just a function. So get this f prime. I hope you know how to write this f prime x. Okay, f prime x. If this limit does exist, we say f is differentiable. This is differentiable at this point is x. Okay, and finding a derivative is called differentiation. This means differentiation, and the part of calculus associated with the derivatives is called differential calculus. Okay, for example, we should cover the answer and try by fx here. Fx is x cube. This is x cube plus 4x. Try to find f prime x. Maybe I should write f prime x here. Okay. By definition, we know f prime x. F prime x is equal to limit h approaches 0. Fx plus h minus fx over h. Okay, here. Now we say fx is here. Example 1, fx is x cubed plus 7x. Example 1. Find f prime x. Okay, try. Ever try? Solve this example of this example 8. Example 2. Yeah. I hope you can finish one during this time. Hello, students online. Please try to solve try to find f prime x. Okay. Uh, 3x squared plus 7. The answer is right, but what's your precise? How to calculate it? Your name this ID is 14. Can you share your answer? Just the final answer. You can take a picture to send. Okay. Oh, dx xn. X power n is n x 14. Hello, your Chinese name. I don't know your Chinese name. You have learned it before? 14. Okay, so if you remember this formula, then it's easy for you. In college, not in high school. Let me see, Lily. Oh, okay. Let me see, yeah.